All right, guys, we're on the back side of day 6 notes, and up at the top, we also have to talk about finding the perimeter of a shape, okay? Perimeter, just remember, guys, is the sum of all sides. When they say sum of all sides, they really mean sum of all lengths of the sides, okay? And length is distance. So when they have to find the length of each side, remember to use the distance formula. That will find the length, all right? And once you find all the distances, then we'll add each of them together. So here we go. And number 2, it says that a polygon has vertices at A, B, C, and D, and they want you to find the perimeter of the polygon in simplest radical form. So we have to go ahead and graph it. So A is at -7, -2. B is at -4, -4. C is at -6, -6. Okay. And D is at -9, -6. And I'm just going to move my B out of the way because he's kind of in the way. We're going to put B a little bit closer to where he is so he's not in the way of us and counting. Okay. All right. We'll go ahead, guys, and connect those points. And what we have to do, guys, in order to find what they are asking for perimeter, that's different than what we were doing on the front. On the front, we were finding area, so we used area formulas. On the back, perimeter, guys, perimeter is the length of all the sum of all the lengths of the sides, and so length is distance. And so we have 4 distances to find, although one of those distances is very simple because it's a horizontal line and you can count the length of it, all right? The other sides are diagonal line segments, and we can't count those, all right, to find out how long they are. So we'll go ahead, guys, and go in order, and we'll do the distance of AB first. All right, so we'll be finding the length of this side here. Because it's a diagonal line, we can't just count blocks. We actually have to do the distance formula. All right, and remember X is first, and so we'll do -7 and -4, and -2 and -4 for the Y's. Okay. And we're just going to go across here, I think. So -7 minus a -4 is really the same as -7 plus 4. And -7 plus 4 is -3, and -3 squared is 9. Here we have -2 plus 4, which is 2, and 2 squared is 4. And when we add them together, we get the square root of 13. Okay, so this side right here is the square root of 13. All right, next up, we'll do the distance of, let's see, that was AB. We'll keep track of them. And so now we have to do the distance of, let's say, BC. And we'll go ahead and grab the X coordinates from B and C. So that's -4 and -6. And the Y coordinates are -4 and -6 also. All right, so here in the front, -4, and that's really +6, which is 2, and 2 squared is 4. Here, -4 plus 6 is 2, and 2 squared is 4, and so this gives me the square root of 8. And so now that side is finished, all right? Distance of CD. Now we could do the same thing. However, I already know that the answer is going to come out to be 1, 2, 3. All right, because I can count blocks on a horizontal line. So let's take a break from that one, and we'll do that way. All right, and then we only have one side left to find the distance of. And the distance of DA or AD, doesn't matter, is not a horizontal or vertical line, so I cannot count blocks to find how long it is. So I will use the distance formula. And D and A's X coordinates are -7 and -9. And their Y coordinates are -2 and -6. Okay. This is really -7 plus 9, which is 2, and 2 squared is 4. This one here is -2 plus 6, which is 4, and 4 squared is 16. And when you add them together, you get the square root of 20. So we'll put the square root of 20 here. And now we have the lengths of all four sides, and now we can go ahead and add them together. All right. Now they did say simplest radical form up in the directions. Cool thing about 13 is already simplified. Cool thing about 3 is already simplified. And so we only have 2 here to simplify. So the square root of 8 will break up into the square root of 4 and the square root of 2, because 4 times 2 is 8. And the square root of 4 is going to become 2 square root of 2. So we'll use that instead. And that one's now been simplified. Square root of 20 is the square root of 4 and the square root of 5, because 4 times 5 is 20. And the square root of 4 becomes 2 square root of 5. And so we'll use that as the simplest form. All right. And therefore, in simplest radical form, all right, so our perimeter is going to be our first side of square root of 13 plus our second side of 2 square root of 2 plus our third side of 3 plus our last side of 2 square root of 5. And if you think back to when we added radicals, they have to have the same number underneath the radical in order to be added together, and none of these do. And so we're going to leave that lovely expression as our perimeter. Okay. Now in part B, it says find the perimeter to the nearest tenth. Because it says nearest, everything's going in our calculator. So in our calculator, we're going to type in the square root of 13 plus 2 square root of 2 plus 3 plus 2 square root of 5, and we're going to hit enter. And when we do, we get a decimal of 13.906, 11, dot, dot, dot. And because they said to the nearest tenth, that's the 9. Look next door. Not going to round it up. And so we'll say 13.9 is the perimeter in nearest tenth form. Okay. And there we go. All right. So let's take a look at number 3. And in number 3, it's saying that we have a triangle called RST, and it's already graphed for us, which is awesome. And in part A, they want to know how many square units are in the area of it. So thinking back, area, we're going to use our area formulas. And remember, the trick is, because this triangle is a little lopsided where we can't find the area of the triangle because we can't figure out the base and the height. Anytime we're doing area, we're going to put that box around it, okay? And so if we go straight up from S and straight over from R, that's going to be one corner of our box. Okay. If we go straight down from S and straight over from T, there'll be the second corner of our box. And straight up from T and straight over from R. Okay. There's the last corner of our box there. So we're going to go ahead and say the area of the rectangle minus the area of triangle 1 minus the area of triangle 2 minus the area of triangle 3. If we take those 3 triangles out of the area of the box, we'll have the area of our triangle left over. All right. So now time to fill in with formulas. Area of a rectangle is base times height. Area of a triangle is 1/2 base times height. And again, and again. All right, so we just have a bunch of bases and heights to find. So for our rectangle, our base and our height. So look at the big rectangle that you put around the shape and go ahead and count from corner to corner. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this rectangle is actually a square. Good news, you find the area of it the same way. So there is 144 blocks inside that box that you put around your triangle. And now we're going to take some of those boxes out. Okay? And so our first triangle that we called triangle 1, we need to know the base and the height of it. So this is the triangle we called triangle 1. Okay? And remember, base and height have to be perpendicular. So you're counting the 2 sides of the triangle, which are called the legs. So 1, 2, 3, 4, 5, 6 by... Oh, we already counted that. That whole length there is the same length as that. So it's 6 by 12 for the base and the height. And 6 times 12 is 72, and half of 72 is 36. So we're going to take 36 blocks out of the 144. But that's not all. We're going to look at triangle 2, find the area that is in there. So in triangle 2, cool thing is, if this is triangle 2, we already have one of its legs counted. This leg here is 12. We just have to count the top leg there. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that triangle is 9 by 12. All right, 9 by 12 is 108. Times a half is 54. So we're going to be taking 54 blocks again out of that 144 total blocks. Okay. Here we have one last triangle to do. And we need to know the base and the height of it. So triangle 3, it looks like this is 1, 2, 3 by 1, 2, 3, 4, 5, 6. 3 by 6, which is 18, and half of 18 is 9. So out of the 144 blocks inside the big rectangle that we put around it, we're going to take 36 out from triangle 1, 54 out for triangle 2, and 9 out for triangle 3. And that will leave me the number of blocks that are inside that black triangle that I shaded in called triangle RST. So 144 minus 36 minus 54 minus 9, hit enter, and you end up with 45 units, its area, squared. And there is the area. Okay. All right, let's take a look, guys, at the last question there. And they're asking me to determine the perimeter of triangle RST. So because the key word is perimeter, perimeter is the sum of all the lengths of the sides. And since I do not know the lengths of my sides, I'm going to have to go and find them. All right. Let's see, did they give us coordinates? They did not give us coordinates. So I'm going to go ahead and write down my coordinates. It'd been nice if they gave them to me, but they didn't. So I can pull them off the graph. So if I look at R's coordinates, it's at -2, 7. Our S's coordinates, S has coordinates of -5, 1. And T's coordinates are 7, -5. All right, we're going to go ahead and find the length. And I'm just going to do me a favor. I don't need any of this stuff anymore. So I was hoping I could erase it, but it's not letting me erase. Nope, there we go. All right, so all of that was for area. Now that I'm finding perimeter, I really don't need any of it. All right, I'm just going to find the lengths of those 3 line segments. And length is distance, and so we'll start with our distance formula, and we'll do the distance of RS first. And R and S, remember X coordinates first, guys. And so we're going to do -5 minus a -2, and then Y coordinates second, which would then be 1 and 7. All right, let's clean this up a little bit. This is really -5 plus 2, which is -3, and -3 squared is 9. Here, 1 minus 7 is -6, and -6 squared is 36. And if I add them together, I get the square root of 45. Okay, now they did say simplest radical form, so I'm going to go ahead and break this up into 9 and 5. And that becomes 3 square root of 5 for the length of RS. Okay. Now we'll go ahead and do the distance of RT. And R's x-coordinate and T's x-coordinate is -2 and 7. And 7 and -5 for the y-coordinates. And we'll clean this up. -2 minus 7 is -9. -9 squared is 81. And this is really 7 plus 5, which is 12. And 12 squared is 144. And when I add them together, I get the square root of 81 plus 44, which is 225. And what's nice about 225, I don't know if you guys know, but it's perfect. It equals 15. And so the length here of RT is 15. That one ended up being nice. Okay, we have one last side to find the length of before we can find the perimeter. and that's ST. S has coordinates, and we're going to steal his x coordinate, which is -5 and 7. Oops. And then y coordinates are 1 and -5. All right. And clean this up a little bit. -5 minus 7 is -12, and -12 squared is 144. Here, that's really +1 plus 5, which is 6. 6 squared is 36. And when we add 144 and 36, we get the square root of 180. And 180 is not perfect. 36 is the largest perfect that goes into it 5 times. And that's going to turn into 6 square root of 5. All right, guys, we are now ready to find our perimeter. And so our perimeter is equal to 3 square root of 5 plus 15 plus 6 square root of 5. And 2 of these will go together. 3 square root of 5 plus 6 square root of 5 are like because they have the square root of 5 underneath. And so we add the numbers out in front, and 3 and 6 is 9. So we end up with 9 square root of 5 plus the 15. The 15 cannot get added. All right, guys, and that is our final perimeter. So hopefully that helps you find the area of a shape on a graph and the perimeter of the shape on the graph. All right, just pay attention to which one they're asking, okay? All right, I'll see you guys in the next day of notes.